Okay, before you start doing this exercise, you should have done two things. One is you should watch the video about um, instantaneous compounding that is given by a YouTuber. The other thing is you should do the investigation, the at-home investigation about instantaneous compounding. Okay, so if you've done those two things, go ahead and start the exercises. There's not really too much from the book reading here. It's mostly just the problem. So I'm just going to work a few problems here. Sketch on the set of axes the graphs of y equals 2 to the x, y equals e to the x, and y equals 3 to the x. Comment on any observations. Okay, so if we take any of these three, the first value is going to be the multiplier out front, which is 1 in every case, right? So 2 to the 0 is 1, e to the 0 is 1, and y 3 to the 0 is 1. So like all these graphs start out at the point 1, 0, comma 1. What about the second point? 1. So I'm going to use different colors for each one. So we'll use red for this one, and we'll use blue for this one, and we'll use purple for this one. Okay, so let's graph some points for 2 to the x. So the first point would be 1, the second point would be 2, the third point would be 4, the fourth point would be 8. 1, 2, 3, 4, 8. Okay, and then I'm going to graph the blue one. So 3 to the x, first point is 1, second point is 3, oops. The third point is 9, okay. And if I want, I'm going to connect these points, okay? So like blue, I'm going to connect like that. Red, I'm going to connect like that. And now let's do e to the x. E to the x is a little bit tricky because it's not whole numbers. So it starts out at 1, or at 0, comma 1, and then 1, comma, now remember, e is like 2.71. So 2.7 to the 1 is 2.71. So it would be between the red and the blue value here, 2.71. And then the second value would be 2.71 squared, or you'll notice your calculator has an E button, if I can find it. Do you see it here? I don't see it. Oh, there it is. You go second e to the x. Oops, that's not what I want. Second e to the x. Okay, and then I put 2 because I want e squared. E squared is equal to 7.38. So 2 comma 7.38 is right there. Now you're starting to see a pattern here. Okay, now let's draw the graph of e. Okay, and then it says, so draw those three lines, and then it asks you, what is the relationship between the three? Is that what you would expect? Well, they're all very close together, right? What else is related among them? Which one's highest, which one's lowest? Well, 3 to the x is the highest, 2 to the x is the lowest, and e to the x is in between. Does that make sense? Yeah, because 2.71 is between 2 and 3, so if I put 2 to the x, 3 to the x, and 2.71 to the x, then I should expect the same behavior. I should expect that 2.71 to the x is kind of between 2 to the x and 3 to the x. Okay? So 2 to the x and 3 to the x are both exponential functions we're familiar with. E to the x is not really anything different than that. It's just between the two. Okay, so you can kind of see that in this graph. Okay. I'll skip that one. Okay. What about this one? Consider y equals 2 e to the x. Explain why y can never be less than 0. Well, why don't we try to make it 0 to start out with, okay? Well, what if we put 0 in for x? What do we get? Well, if you remember, if we put 0 in for an exponent, it'll always give you 1 for e to, like it would be e to the 0 would be 1. So y would be 2, okay? So 0 gives us 2. So 0 didn't work. You've been giving a negative number. What if I put a really big number? What if I put 100 in there? E to the 100, what would that be? It'd be a huge number. Okay, so 100 gives us a huge positive number. Okay, well, what if I put a really negative number then? I'm going to put like negative 100. So e to the negative 100. Well, that would just make, that would be 1 over e to the 100. So this would be a huge number on the bottom. It would be a fraction with those 1 on the top and a huge number on the bottom. It would be very close to 0, but not quite 0. Okay? And so it would just be, it would be like a really small number, but not 0. And then, so how can we even make it 0? Well, it turns out we can't. We can't, no matter what. No, if you put a real big number, it turns into a real big number. If you put a real small number, real negative number, you just get a really small number that's close to 0, but you never get there. And the reason why is because remember, there's a horizontal asymptote whenever you draw an exponential function, and the exponential function is approaching 0, but it never gets there. So not only does y never become less than 0, it never even becomes 0. So actually, y is always above 0, more than 0. Okay. Now, let's take one of these problems like this. Obviously, you're not going to do this without a calculator. How do we do it? Well, we just showed you that to do a exponent e, you do second log, and then you put any number here. So even if it's a fraction or a decimal, no problem. The calculator can figure it out. So that's about equal to 2.01. And that's 3 significant figures, you see. 1, 2, 3 significant figures. Do you know how to do significant figures? Significant figures is, if it's not a 0, then it's a significant figure. Any 0 that's between 2 significant figures is a significant figure. So this here is 3 significant figures. Okay, write the following as the power of e. I think the trickiest one is probably this one. So we'll do this one first, okay? So we'll have 1 over square root of e. Well, 1 over square root of e, square root of e is e to the 1/2, right? And now it's the inverse of e to the 1/2, so we could say e to the negative 1/2. And then we're just done, okay? We'll take this one here. Simplify that. Okay, so remember that if you have an exponent to an exponent, you may multiply these exponents together. So let's try to do that. 0.064 divided by 16 times t. You could use the calculator, but you could probably do this in your head too. 0.064 divided by 16 is 0.004. And I'm going to check that with the calculator because that's kind of a tricky one. 0.064 divided by 16. 0.004. Good. Okay, so I simplified it, and it's that 0.004t.